Welcome back to this intermediate Java course. This course is a presentation of coding boot camps. This is session 9 and we will discuss Java database connectivity. In our previous session, we discussed threads in Java and we reviewed all of these topics. So here is our session 9 outline. Again, Java database connectivity. We will look at the SQL package for Java, the JDBC architecture and drivers. We'll look at some SQL exceptions, drivers and managers, connection statements, results set interfaces, basic query and update, improving performance with the prepared statement and callable statement interfaces, and JDBC transaction management. So the Java SQL package includes all of the classes and interfaces necessary to perform almost all JDBC operations, such as creating and executing SQL queries. So JDBC stands for Java Database Connection, and SQL stands for Structured Query Language, and Structured Query Language is a relational database language. If we take a look at some of the classes and interface of the Java SQL package, we can see here we can have the blob, and the blob is a binary large object which is used in a database. We have connections, callable statements, clob, and that's a character large object which is also a database data type. We have the SQL date functionality. We have the driver manager, and we also have the prepared statement. So let's look at the JDBC architecture and discuss drivers. So again, JDBC stands for Java Database Connectivity, which is a standard Java API for database independent connection between the Java programming language and a wide range of databases. The JDBC library includes APIs for the tasks mentioned below that are commonly associated with database usage. So for a large part are applications, particularly web and mobile applications that require a database, which almost all of them do. So making a connection to an external database, building and creating SQL or MySQL statements. These two are almost always identical. Executing SQL or structured query language queries within a database. And MySQL is a brand of database, and it's almost always identical with SQL with certain exceptions. And then viewing and modifying result sets. So when we make a connection or run a database query, we get some kind of a result set. And if we look here, the JDBC architecture and drivers. So this is a diagram which shows the location of the driver manager with respect to the JDBC drivers and a Java application. So a driver really is an external device application which will allow connections between Java and the external database. So we see here Java application, we see the JDBC API and the driver manager, and the driver manager has for us different JDBC drivers depending on the vendor or the brand of database we're using. So there are Oracle JDBC drivers, there are JDBC drivers for SQL Server, which is a Microsoft product, and then there is the open database connection for a data source JDBC driver as well. So something that can be useful in database programming in Java are the SQL exceptions. So an SQL exceptions can, an exception can occur both with the driver or with the database. When such exceptions occur, an object is passed of type SQL exception, and that'll be passed to the catch clause. The passed SQL object has the following methods available for retrieving additional information about the exception. So get error code, this gets the error code number associated with the exception. get message. This gets the JDBC driver's error message for the error and allows for troubleshooting. The get SQL state gets the SQL state string for the JDBC driver error. No useful information is returned from this method. For a database error, the 5-digit XOpen SQL code is returned. This method can return null, but is still worthwhile returning anything in. It will help you troubleshoot. Get next exception gets the next object exception in an exception chain. The print stack trace prints the current exception or throwable, and it backtrace to the standard error stream, and print stack trace prints this throwable and its backtrace to the print stream you specify. Here we'll discuss the driver manager, the connection, the statement, and the result set. So statement objects allow you to execute your SQL queries. So a query could be a select statement, could be an update, could be an insert, and retrieve the results through a class called result set, which we'll look at later. To create a statement instance, you call the create statement method on the connection object you have retrieved using one of the driver manager get connection. So first we have to make a connection, and then we can call the methods described. We make the connection and that returns an object. Please check your Oracle documentation for more information on the connectors. A result set. So a result set is that list of records or a Boolean or some data that comes back from our database connection. So a result set object maintains a cursor. So it is a multi-dimensional data structure almost always, even if there is just one element, and there is a cursor or a pointer pointing to each record. So a result set maintains that pointer to the current row. Initially the cursor is positioned before the first row. The next method moves the cursor to the next row, and because it returns true or false when there are no more rows, the result in the result set object, it can be used in a while loop to iterate through the result set. So if our result set returns 10 records, what we can do is, one of the ways is to use a while loop, and we can test to see if there is one more record in the result set, and we can return each of those records one at a time. So if you look closely here, here is an example of our connection statement. So we are making a connection to an external database, and we are returning the statement object here. Then we have our result set class. So we see it's being instantiated here. So we're taking our statement, our connection statement, calling execute query on it, and we're passing in a string, which is actually an SQL query. So we can see this SQL query will run, and it will return a result set here to RS, and it again is of type result set. So, and what will happen here, this is multi-dimensional. There could be several rows, and there will be a cursor or an iterator, and each time we move the iterator, we can return the values that are in each of those rows. So here's an application, and this is a good application, a Java class here for making a connection to a database. You can see we're importing Java SQL, and our class is Java example, and we have our database driver here, and we have our database URL. And so these are both required. We have our database connection username and password, and here is our main method. So we null out our connection and our statement, and what we do here is we have our try, and we pass in our database driver and where that is, and we print out are we connected, and then we pass in our URL connection and our username and password, and then we have full user database connections. Then we want to execute the query, so we can use a creating statement for debugging. we create our statement based on the connection. So when we made our connection, we got statement back, or the statement object, and then we build our SQL string, which is nothing more than just a string object, and then we pass our SQL string to our execute update that's being called on statement, and then this update will run, and we will be able to see that result set. So this is not returning anything because an update doesn't return anything. Typically it doesn't. There are ways to get results though, whether it was a pass or a fail. And now we can actually then reuse these statements here for a result set. So we build another SQL string. You can see here this is a select statement, and then we take this SQL, we pass it in here to execute query. We call execute query on statement. That returns a result set, and what we can do is iterate through that result set. Again, if it returns 5 records, we can iterate through all 5 records and actually get their values. So here is a continuation, and this is a good example here of moving through a result set. We're calling next on RS, which is our result set. So if there is next or another record, it'll return it, and we can see in this case we are looking for 1, 2, 3, 4 columns. So here we are going to return the data from the ID column back to ID for this iteration of the loop. Age back to age. We're going to return first name and last name as strings here. Then we're going to display each record. So this will loop for if there are 10 records, if the cursor is pointing to the first record, and if there's a second, this loop will continue to iterate until there are no more records in the result set. And then it's a good practice to close the connection. Here is some exception handling right here. Again, it's a great idea to actually try this to really understand it. This you can actually use the visual debugger and walk through line by line, but you have to have the database installed. You have to know where the driver is. So there is setting this up does require a little bit of work, but once you have it running, building an application like this is very straightforward. And running a simple application like this gives you a great understanding of Java and database connectivity. So let's take a look at improving performance with prepared statement and callable statement interfaces. So here are some interfaces here. So statement is used for general purpose access to a database, useful when you're accessing static SQL statements at runtime. The statement interface cannot accept parameters. So prepared statement, when you plan to use SQL statements many at a time, the prepared statement interface accepts input parameters at runtime. And the callable statement, use this when you want to access the database stored procedures. The callable statement interface can also accept runtime input parameters. So stored procedures are database applications or database programs, and they do the stored procedures will return data. They do take parameters, and they do have to be called. So callable statement will allow you to call those database programs, a little bit different from queries, which really just give you the data in the database or update or add data to the database. The stored procedures are actually database programs, which, like Java, will return data and also may need to accept parameters. So it's a bit of a different way of working with the database. So if we take a look here, we can see that these are stored procedures for Oracle. You can see here that there actually are parameters that need to be passed in, and then this SQL code is executed. This is also a similar process here. So these need a different way than just simply querying, updating, or inserting. These types of stored procedures need a different way of interacting. So the callable statement object, that's what it's there for. And again, this is a framework of using the callable statement. So we make our callable statement, we set our callable statement object here. Well, in this case, it's set to null, but we would set a string. And then we would take our connection and our prepare call. We would pass in our SQL statement, which it looks like it's prepared for us up here, and then it would go through the rest of the try block. If there was an exception, it would be sent to the catch block, and then the finally block would eventually run. So the string variable SQL represents the stored procedure with the parameter and placeholder. So we're calling this stored procedure with these parameters and or placeholders. So if we look at JDBC transaction management, your JDBC connection runs by default in auto commit mode, which means that once you complete your SQL statement, the database transaction is automatically committed to the database. So updates are automatically committed. Any other inserts that you do are automatically committed. Sometimes that is important to do. What this does is really prevent you from committing on your own and rolling back if you need to. But there are 3 reasons why you may want to turn auto commit off. Well, increase performance, but you have to remember, if you do want to commit, you do need to call the commit explicitly and to maintain the integrity of business processes. So that may mean that if something doesn't look right, the database can be rolled back, and also for distributed transactions. So if we don't want auto commit, we call set auto commit and we pass in false on our connection, and that will turn off our auto commit. And now we can commit and roll back explicitly. So if any transactions that we've completed on our database are all successful and look right, we can call commit on our connection. Otherwise, if there were any kind of problems, we can call rollback, and the database will go back to the state as it was before the transaction. So take a look here. Let's take a look at this. It's not a complete application, but you can see here we're using our try catch because we could introduce an error because of problems with the database connection. But we're assuming a valid connection. And we are calling on our connection set auto commit and passing in false. So now we are creating our statement. So we have our connection and we're calling create statement, and we have our statement object. We build our SQL query right here. So notice how we're building it. And then now we take our statement object, call execute update on our SQL, which is right here. We submit a malformed SQL statement here, so something doesn't look right here, and then we call execute our update on that SQL. We test here. If there is no error, we commit. However, if there is an exception, remember the exception is returned to the catch block, we can call connection rollback. So that means that any type of issue, any type of problem that occurred, any type of update that occurred and returned an error, the database will be rolled back to the state that it was before the transaction was attempted. And error information, just like we talked about, can also be returned back to the user, and the user can take action. So in this session, we discussed Java database connectivity. We learned about the Java SQL package, the JDBC architecture and drivers. We learned about SQL exceptions, the driver manager, connection statement and results set interfaces, basic queries and updates, improving performance with prepared statement and callable statement interfaces, and JDBC transaction management. In our next session, we will discuss Java web applications, and a lot of this also covers mobile applications as well. We'll look at Java Enterprise Edition application servers, and we'll discuss servlets and HTML and retrieving request parameters, as well as other Java web application topics. Please consult your learning materials on private tutoring sessions for Java, and also private tutoring sessions for Java programming. Thank you for taking the time and watching this video. This course is a presentation of Coding Boot Camps.